and welcome to Dr. G's Technique of the Week, Geometry Edition.
Today we're going to be reviewing special right triangles and then utilizing special right triangles to solve some fun little geometry problems. So to start off, let's look at 45, 45, 90 triangles. As with most things in mathematics, these are not named in any sort of mysterious or magical way. They're just named for the measures of the angles in the triangle. So a triangle that has 45 degree, 45 degree, and 90 degree measures for its three angles is a 45, 45, 90 triangle. And in a 45, 45, 90 triangle, we know that the sides, the length of the sides, are always in ratio 1 to 1 to root 2. And then it can scale up from there. So for example, if we have this triangle here at the top right, in which one of the legs is 10 millimeters, and we see that it's a 45, 45, 90 triangle, that tells us that the other leg is also 10 millimeters. It's the 1 to 1 part of this ratio, and that the hypotenuse is just 10 root 2 millimeters. Right? The square root of 2 times 10. Or if we know the hypotenuse, like here at the top left, if we know the hypotenuse of a 45, 45, 90 triangle is 7 root 2, that's the root 2 part of this ratio. That tells us that the two legs must just be 7. Now you try one. Let's look at this triangle at the bottom left with one leg being 9. Try and find the value of the hypotenuse. So since the leg is 9, we know that the other leg is 9, and we know that the hypotenuse is just 9 times the square root of 2. So that's going to be our Q. Now try this one at the bottom right. If the hypotenuse is 4 root 2, what is the length of the leg going to be? Well, we just look at whatever number is multiplied by the square root of 2 to give us the length of the hypotenuse, and that's 4. So that means that Q, the length of this leg, must be 4. So that's the 45, 45, 90 triangle. The sides are always in that same ratio, that 1 to 1 to square root 2 ratio. All right, now let's consider the other type of special right triangle, which is the 30, 60, 90 right triangle. Again, this name just refers to the angles that are in the triangle. So if you have a triangle whose three angles measure 30 degrees, 60 degrees, and 90 degrees, then you have a 30, 60, 90 special right triangle. And we know that the side lengths in a 30, 60, 90 triangle are always in the ratio 1 to root 3 to 2. And this is in order from longest to shortest. So this is the shorter leg, the longer leg, and then the hypotenuse. So the hypotenuse is twice as long as the short leg, and the long leg is the square root of 3 times the short leg. So for example, in this triangle at the top left, we know that the short leg is length 4, and we want to find the length of the hypotenuse. Well, going to our ratio, we know that the hypotenuse is just twice as long as the short leg. It's a 2 to 1 ratio. So that means that this hypotenuse must have length 8. So what do you think about this one here at the top right? If the hypotenuse is 18 yards and we want to find the length of that short leg, what will it be? So since we know the hypotenuse is twice as long as the short leg, we just divide 18 by 2. We know that that side must be 9 yards. And now here, at the bottom left, we're dealing with the long leg, and we know that the long leg is 6 times the square root of 3. That square root of 3 is in our ratio for the long leg. So we know the short leg length is just going to be the number that is multiplied by the square root of 3 there, which is 6. So that tells us that our short leg will be 6. What about the other way around? So here at the bottom right, we know that the short leg is 7 yards, and we want to find the length of the long leg. What do you think? Good. So since we know that the short leg to long leg ratio is 1 to root 3, if the short leg is 7, that long leg must just be 7 root 3. So now let's apply these to some more interesting problems. Here we're given an equilateral triangle, ABC, and we're told that the length of AB is 4, and we want to find the area of the triangle. So first, how do we find the area of a triangle? We want to be able to use our area formula, 1/2 times the base times the height. And since this is an equilateral triangle, we know all of the sides are the same length, so we can get that length of the base pretty easily as 4. We still need to find the height of this triangle. So I'm going to draw the height in. So what do we know about the angles in an equilateral triangle that can help us out? Since an equilateral triangle has 3 equal angles, that tells us that the 3 angles in this triangle, the original triangle, must be each 60 degrees. So these bottom angles are both 60 degrees. And since the height bisects angle A, tells us that each of these smaller angles measure 30 degrees. And so we have a 30, 60, 90 right triangle. And so we can use that to find the height. Since half of the base is this short leg, that's just 2. That tells us that the height is 2 times the square root of 3, just using that 1 to square root 3 to 2 ratio that we know for 30, 60, 90 special right triangles. And then we can just put in our base and our height for this area. 1/2 times 4 times 2 is just 4. So the area is 4 root 3 square units. Now here's a problem to think about. If the perimeter of a square is 16, we want to find the length of its diagonal. So to work on this, I recommend drawing a picture of a square, label its side lengths so that the perimeter will be 16, drawing the diagonal, and then think about what you know about the angles in that diagram to identify some special right triangles that you can use to find that length.
Now it's time for you to get some practice with these new ideas. See you next time on Dr. G's Technique of the Week.